Mass spectrometry. At its core, mass spectrometry is simply studying the masses of atoms or molecules, or even fragments of the molecules based on their mass to charge ratio. And we'll dive into how we use the mass to charge ratios in our data from a mass spectrometer in later videos. But in this video, we're going to look at what is the kind of general process of mass spectrometry and the basic parts associated with a mass spectrometer. At its core, at its basis, we have some kind of an inlet that's going to introduce the sample into the system. Now, our samples might come in the gas phase already, or they might be in a liquid phase, and we need to then put them into the gas phase. We also need these to be charged, hence the mass to charge ratio that we're going to be looking at. And so from the inlet, we need to put these into an ion source that's going to ultimately ionize the sample. Now, sometimes the inlet and the ion source are merged together, but the inlet is going to merge with, if there's some kind of previous instrumentation, such as a chromatography technique or perhaps an ICP, that inlet might be different depending on each kind of merging with your previous analyses. Okay, so the inlet's going to get us into the gas phase. Our ion source is going to ionize the sample, and again, these two could be combined to where you're taking something and getting it in the gas phase and ionizing it at the same time, and we'll look at an example of that later on in this module. Now, from the ion source, we're going to take the ions that we form and we're going to analyze them. We're going to do this in some kind of a mass analyzer. Okay, there's a variety of mass analyzers available. Some are going to give you more precise measurements than others, but ultimately it's going to do some kind of separation of the ions based on their mass to charge. So unlike chromatography, which would separate ions based on things like polarity or boiling point, this is going to separate ions based on the mass to charge ratio. So any of the ions that leave the ion source are going to be separated in the mass analyzer. From the mass analyzer, we're going to go to some kind of a detector. Now, much like the inlet and the ion source can be sometimes merged, mass analyzers and detectors are sometimes one and the same as well, where the method of separation of the ions and detection of the ions happens at the same piece of instrumentation. And we'll look at an example of that with the time of flight mass analyzer a little bit later. Finally, we have a signal coming from the detector, which we're going to read out using a computer. And like we've talked about earlier in this class, where detectors might have some kind of a current that's then converted into an intensity, we've got that same kind of conversion of domains going on here from what our detector reads to giving a computer readout. And that computer readout, we would call this a mass spectrum. The plural of that would be mass spectra with an A at the end. And a mass spectrum has your mass to charge on the x-axis and some kind of intensity on the y-axis. This can be in terms of number of ions or number of a certain fragment of ion, depending on, or total number of ions of that mass to charge. Okay. Now, this is a good system here. There's one other thing that we need to add to this diagram, and that is a vacuum pump. Now, the mass analyzer and the detector, if they are one and the same or if they're different, it doesn't matter, but both of these are going to be held under vacuum. And what does that mean here? So the vacuum pump is going to pull out all the air and make this a a very low pressure system. There's not very many gas molecules. And the reason we want very low gas molecules around the mass analyzer and the detector is so that we avoid collisions. Because when you have collisions in the gas phase, you can end up with reactions occurring, and that's going to change what our analyte or our ion is if it's reacting with another gas. So we typically have this under a vacuum pump. Now, there are options that allow you to work under higher pressure with controlled collisions, and some interesting chemistry that goes on with that. But for the purposes of this introduction to mass spectrometry, most mass analyzers and detectors, at least the ones we're going to look at in this module, are going to be held under vacuum. If you're interested in some of the more interesting nuances of high pressure systems, you should consider taking the mass spectrometry course that's offered each spring. Now, our mass analyzer and detector are pretty much always held under vacuum, and some of our ion sources are held under vacuum as well. So your inlet, possibly your ion source, more often your ion source than your inlet, are going to be under vacuum as well. Okay, so these are the basic parts to a mass spectrometer and what they do, and in later videos we'll dive into more depth about ion sources, mass analyzers, and detectors.